So I'd like to start off this session with a little story. It's Terraform all the way down. What does that mean? Well, long before humans stepped foot on the moon, or put satellites in space, or Galileo turned his telescope to the stars to understand our position in the solar system and the universe, there was a common belief across the world, from India to Europe to ancient North America, that the world was actually riding on the back of a giant turtle. The world turtle is what this was called. And as with any belief, people sometimes questioned it. Well, if the world is riding on the back of a giant turtle, what is that turtle riding on? And the logical answer here, of course, is, well, it's riding on another turtle. Which begs the further question, well, if that turtle is on another turtle, then what is that turtle on? And the only logical answer, again, is, well, obviously, it's turtles all the way down. Today, we can actually replicate this with Terraform and Kubernetes, and that's what I'm going to show you in this session today. But first, before we get started there, I have a very exciting announcement. I'm announcing the general availability of the Kubernetes Manifest resource. So what is the Kubernetes Manifest resource? Well, if you've been following along with us, we have been trying to create a resource that allows you to cover all Kubernetes resources within Terraform. And we started this project with a new provider called the Kubernetes Alpha provider. And this provider had one singular resource called the Kubernetes Manifest resource. And this resource is an analog for your YAML Kubernetes manifests. And this is a huge advancement for the Kubernetes provider because it allows you to apply custom resources or really cover any resource within Kubernetes using HCL that acts as a YAML analog. And recently, we moved that resource out of the Kubernetes Alpha provider and into the main Kubernetes provider as a beta feature, which you had to enable using an experiments feature flag. Well, today, that resource is generally available. And not only does it cover many more resources, including custom resources and custom resource definitions, it also uses server-side apply, so we can actually leverage Kubernetes as the source of truth instead of just relying on the Terraform state. And we also built in support for managed fields, and you can select and specify which fields you want Terraform to ignore after you apply. So if you're running operators or things upstream in Kubernetes that are changing some of the fields, this will no longer cause a perpetual diff for these Kubernetes resources. So this is a much improved experience with the Kubernetes provider, bringing in all support for all objects within Kubernetes, including our custom resources, custom resource definitions. You can now install operators. You can do anything that you can do with YAML, you can now do with the Kubernetes provider. And I'm very excited that this is generally available today. And we'll go into this a bit later as well. Okay, so I want to talk to you a little bit about how to adopt Kubernetes with Terraform and be successful. This is something that I've talked to a lot of you about. I've talked to many, many users. I've talked to many companies about how you're using Terraform and Kubernetes. And I've come up with a pyramid of success for adopting Terraform and Kubernetes. And this pyramid has multiple layers. It has a cluster layer, the core layer, and the app layer. So let's break this down. The cluster layer is probably what you think it is. It is the layer of your config where you're applying and creating your Kubernetes cluster. This could be EKS, this could be AKS, this could be GKE. This could be many, many resources that we have to create Kubernetes clusters, which I'll go into in just a minute. The next layer is our core layer or our core services layer. This is the layer where you're installing your infrastructure services into Kubernetes. This could be your cert manager. This could be your ingress controller. This could be your operators that your applications are going to rely on. It could be any of those shared infrastructure services that you're deploying within Kubernetes. And then the last layer, of course, and the reason that we're really using Kubernetes altogether is your app layer, right? And so the pattern for success here is actually to apply these as separate Terraform configs. You can break them into separate Terraform configs, or you can do targeted applies within a Terraform config. I recommend doing it in separate configs, and there's several reasons for this. One is that it lowers your blast radius. It makes your configs smaller and more manageable. The second reason is with custom resources and custom resource definition specifically, and the Kubernetes provider, we need the custom resource definition installed before we can apply the custom resource. And so using this model, we can ensure that our CRD, or custom resource definition, is always available on the cluster before we apply our custom resource to take advantage of that. Okay, so I'm gonna break these down even further. All right, our cluster layer. So this is just a snapshot, a subset of all the ways you can deploy a Kubernetes cluster using Terraform. All of these are providers that are available on the public Terraform registry, and this is just a limited selection. There are many, many more. It is quite possible that Terraform is the most popular way to deploy and manage Kubernetes clusters today. What does it mean to deploy and manage a Kubernetes cluster? If you're familiar with Terraform and Kubernetes, you probably know already. But if not, I'm going to give you a quick demo of what this looks like. All right, so let's get started with this demo. Now, we're going to use a GitOps workflow here. And I'm going to actually deploy my Kubernetes config into Git, and we're going to use Terraform Cloud to deploy our config. In this example, I'm going to use GKE. This is a very, very simple GKE config to get us started. You can see our Git repository here is created and ready for our config, but there's no config in it quite yet. In just a moment, I'll push that up there. And you can see I've gone ahead and created a couple, or a few, I guess, workspaces in Terraform Cloud. I've got our cluster, I've got our core, and I've got our app layer, just like I talked about in our pyramid of success. So you can see I've gone into the cluster workspace here. I've got it all set up. I've already set up our variables that are necessary. Here's the Google Cloud Console. You can see that there's no clusters in here yet. And so I'm going to, in just a moment, I'm going to commit my config, and I'm going to push it up to GitHub. And then I'm going to tell Terraform Cloud to go ahead and apply that config. Now you can set this up to do an auto apply, which I'll actually show you later, but right now I've got it set up to do a manual apply. So after we push it up there, we'll go into Terraform Cloud again. I'll go over to Actions, and we'll start a new plan. Now this plan, I can call it whatever I want. I'm going to call it HashiConf because I'm very excited to be here talking to you about this, and we will go ahead and get this started. So Terraform Cloud will go ahead and run the plan for us, which will take not too long. It will do some cost estimation and policy checks against Sentinel policies. No, I don't really have any Sentinel policies in action here, but if I did, it would check them against them. And then once everything is good, we can see what our outputs are going to be. I can go down and I can click Confirm and Apply. I could do the ever-present looks good to me and confirm the plan, which will trigger the apply. All right, and thanks to the magic of video editing, we have fast-forwarded about 4 minutes to save you some time so you don't sit here staring at a blank screen and watching me talk about, just things in general. So in just a moment, yep, there we go. Our apply has finished, and now we can go over to our Google Cloud Console. We can refresh, we can click either refresh, and we can see that our Kubernetes cluster is there and it's ready to use. Okay, so that brings us to our next layer, the core layer. Now the core layer is a thin cloud agnostic layer that sets up our infrastructure services. And when you're using Terraform, this is really the domain of the Kubernetes provider and the Helm provider. The Kubernetes provider is great for setting up your namespaces, setting up your secrets, putting in your config maps, and creating any roles, access policies, service accounts, and things like that. And of course, you can use it to deploy any custom services that you may have built. Or if you build everything in Helm charts, or have Helm charts that you're consuming from Helm repositories, this Helm provider is a great way to install those in your Kubernetes cluster. So let's do a quick demo of that as well. Okay, so just like our last demo, we're starting with a Git repo that is ready to be used. I have my config. This is a different config now, as you can see. I've got my Kubernetes provider and Helm provider configured to use our GKE authentication and authorization. And I'm setting up 2 infrastructure services. Now, this is just for simplicity. You would probably have many more, but I'm setting up an Nginx ingress controller and the Terraform Cloud Operator, which we'll get into later. And of course, I'm setting up my namespaces, my secrets that I need for the operator. And if you would need them for other infrastructure services, this is how you could do it as well. So just like last time, I'm going to go ahead and push everything up to GitHub into my Git repo. I'm going to call it core services, and then we'll push it up. And once it's pushed up, we can go over. We can see that it's ready in Terraform Cloud. We go into our core workspace, which I set up ahead of time, and we can go ahead and go to actions and start our plan. So just like last time, we started our plan. It's going to go ahead and run through the plan and pause before the apply. It'll do our cost estimation. It'll do our policy checks. I should call out, I'm using Terraform Cloud for demo purposes. You could absolutely, of course, do this in Terraform open source with the CLI or however it works for you. The Terraform Cloud is really nice because it actually gives me a graphical representation of all the resources that it's going to deploy. Makes it quick and easy to look at it. If I hit errors, it is very obvious what those errors are. All right, so our plan succeeded. Looks good to me. Let's go ahead and apply it. Now, this is going to be pretty fast because we're just installing 2 Helm charts. So we'll just wait just a moment for this to apply. And once it's applied, then our core services will be ready for use. And we can go ahead to the next step. So there you go. You can see that our namespace is created, our secrets are created, and our Helm charts are now being deployed into the cluster. So just another moment or two, and they will be ready to go as well. All right, so there you have it. Our core services layer is now installed on our cluster. You can see we have our Nginx ingress controller and the Terraform Cloud Operator and the associated Kubernetes objects that are needed to make those work. Great, so next let's talk about the application layer. Now, when we're talking about Kubernetes, it's really about the apps. And of course, just like the core services layer, we can use the Kubernetes and Helm provider to install our applications, whether we wrote those in-house or we're consuming them from upstream. But it's not just the Kubernetes and Helm provider that we can use. There are many other providers available on the Terraform public registry that match our workflow. Because in Terraform, it's about workflow, not technology. So whether you're using Flux or Spinnaker or Harness or Argo or another CNCF or perhaps a non-CNCF solution to deploy your application to Kubernetes, it's likely that there is a provider already available to you on the registry. And many of these providers are actually built and maintained by the very same people who are building and maintaining these projects themselves. And if they're not, it's likely that somebody in the community has already created a provider that you can use. So this is great. And this is really helpful for deploying our application into Kubernetes. But I don't think it's super valuable to do a demo of this. I think we've done 2 demos. For time, I'm going to go ahead and move on to the next thing that I want to talk to you about, which is the Terraform Cloud Operator. The Terraform Cloud Operator is a operator that manages Terraform Cloud workspaces. So you saw in the previous demos, we walked through Terraform Cloud, we walked through the GitOps workflow with Terraform Cloud, and we saw Terraform Cloud create our cluster and then deploy our core services onto that cluster. The Terraform Cloud Operator, which we installed in our core services layer, installs a custom resource definition that when you apply a corresponding custom resource, triggers the Terraform Cloud Operator to create or manage the entire lifecycle of a Terraform Cloud workspace, including applying your config within that workspace. Now, once that Terraform config is applied, it takes the outputs back to Kubernetes as a secret so that you can consume those outputs in your application or wherever you need them. So what does this look like? Let's get into a demo of this as well. Okay, I realized at the end of the last demo, I never actually showed you that the apps that I talked about, the core services, were installed in our Kubernetes cluster. Now, we can actually see this really easily in the Google Cloud Console, which is nice. And you can see here that the Terraform Cloud Operator, called the Terraform Operator Terraform Sync Workspace, is installed, and that our Nginx ingress controller is installed. Cool. So let's get started with our operator and using the operator. So we're just going to pop over to a YAML manifest. This is the custom resource called a workspace resource that we need to install for the operator in order to get it to work. Now, this resource we're going to call GKE cluster. And when it appears in Terraform Cloud, it will actually concatenate the namespace that it's in with the name of the workspace. So it'll be demo-GKE cluster. We've got our variables that we need for the Terraform Cloud workspace. So we've got a cluster name all the way down. We've got our credentials that we need to authenticate with Google. And then we've got our module source. So this is actually the same cluster that I deployed before. I put it into a module, I uploaded it to the Terraform registry, and now the operator can consume it directly off the registry. And then we've got a couple outputs in here as well. So the Terraform Cloud Operator, as I mentioned before, will take the outputs from Terraform Cloud and bring them back into Kubernetes as a secret. And you can see here we map these from the Terraform Cloud output, for example, Google_zone, into the secret key, which in this case will just be zone. And so if you're going to reference it in Kubernetes, you would just use zone from that secret. You can, of course, make these the same. There's no reason to make them different. So you can apply this as a YAML manifest, but I wanted to show you the Kubernetes manifest resource. And so I used a tool called Terraform K8s that John Houston created that will actually take any YAML manifest and convert it into a Kubernetes manifest resource. Thanks, John. This is really helpful. So I converted it. This is exactly the same resource. You can see it looks very similar, but obviously we're using HCL here. Now, there's a lot of quotes around it. Those quotes aren't always necessary, but it makes it much easier to programmatically create these, and so that's how it looks. So now you can see we still have our HashiConf cluster, and lest you think that I am too good at this or a wizard, I actually did apply this ahead of time to try it out, to make sure I worked out any kinks, and we're going to use this app workspace that I created before, that we were looking at before. And we're going to apply this Kubernetes manifest resource after we push it up to Git. Now, I just have to, of course, commit it. So let's do this. Little overzealous here. Perhaps don't use a bang in your commit message, but all right, I got that. So let's go ahead and push it up. Now, because this is going to dynamically create a workspace and create a new Kubernetes cluster for us, I went ahead and configured the other workspace, the HashiConf Global App Workspace, to automatically apply. So I mentioned that before. You can set it up to not automatically apply or automatically apply. I went ahead and set it to automatically apply. So you can see I pushed it up. The plan is already queued, and it's going to go ahead and apply it after it goes through the entire plan. So we're just going to hang out for just a moment while this does its thing. I'm going to stay on this page so that we can see the new workspace created. And so again, what's going to happen here is Terraform Cloud is going to take our Kubernetes manifest resource. It's going to send it into Kubernetes. The Terraform Cloud operator is going to pick that up and say, oh, I actually have a config. And it's going to send that config up to Terraform Cloud, which is going to create a new workspace. And that new workspace is going to create another Kubernetes cluster for us. So here we go. We're in the apply stage. And you can see our demo GKE cluster workspace is already created. And in just a moment, it will begin the plan and apply stage. And there we go. We've got our plan. And once we hit the apply stage, we'll be able to see that our Kubernetes cluster is actually being created in Google Cloud. So this is pretty cool. I think this is really cool, actually. So let's head over to Google Cloud. Let's do a refresh. And there you can see, there's our new cluster, just as we specified, with its name all the way down. And there you have it. So there you have it. We have Terraform and Kubernetes all the way down. We created a cluster with Terraform. We configured that cluster with Terraform. We deployed the Terraform Cloud Operator, and then we used that Terraform Cloud Operator to deploy another Kubernetes cluster. And we could in turn take this all the way down. We could deploy our core services on top of that cluster. We could deploy another copy of the operator on that cluster. And if we wanted to, we could use that to create yet another cluster for an infinite chain of Terraform all the way down. So thank you very much for attending my session today. It was great to talk to you about this. I'd like to take a quick moment to thank everyone who helped with these projects along the way. Alex, John, Steph, Kyriakos at HashiCorp, and all of the community members that contributed to these many projects along the way. Without you, this would not have been nearly as successful as it is. And thank you for your time. And if you have feedback, please reach out to me directly. You can find me on Twitter, you can find me on LinkedIn, or you can reach out to me at psautter@hashicorp.com. Thanks, everyone.